Alright, so we are solving systems then instead of 2 linear equations with 2 variables, we have 3 linear equations with 3 variables. So we kind of have one extra step that we get to do, okay? The process of how we eliminate variables and then solve for the one and then plug it back in to get the other one is still the same kind of process. You just have to do it twice because you now have to break it down from 3 to 2 and then 2 to 1 and then you work your way back up, okay? So we have the same type of situation where the solution is going to be an ordered pair, or it may be where they're all on top of each other for some, or it may be no solution. Okay, so we still have those possibilities. You could still get something where you get a variable, but then the other solution might be no solution, which means because we have 3 variables, they're coming from different planes now, okay? And so one may work, the other one may not, and we'll see how that works, okay? But they come in here with an ordered pair, and it asks, is this a solution for the system? And just like when we had before with the x and y's, we now have an ordered pair that has 3, and it's always in alphabetical order, left to right. So if you have other variables other than x, y, and z, always put them in alphabetical order. Okay? So let's say it was B, T, and O, for whatever reason. You would want to rearrange that to be B, O, and T. So you always want to have it in the ordered pair alphabetically, A to Z. Does that make sense? Okay? So when you see the ordered pair like that, you're actually looking at the first variable, second variable, third variable. And what this is asking on this question here, example 1, is if I give you this point, this ordered pair, okay, so now we have a multiple plane ordered pair, is it a solution? Meaning if I plug it into each one of these equations, would all 3 of these be true? If the answer is yes, then it is a solution for these 3 equations. If any one of them is no, it is not a solution. And so all we do is take those values and plug them into the corresponding x, y, and z's for that equation. Okay? So if I look at the first one, I would say 3x, I'll put the negative 3, that's my x, that's my y, and that's my z. So I'll just do 3, negative 3, plus 2, and put in my y value of 2, and then plus 4, and put my z value of 4, and equal 11. And so I just want to solve the left side and see if it equals the right side. So I would have negative 9 plus 4 plus 16. And if I add that together, does that equal 11? Well, it's 20 minus 9, so that is 11 does equal 11. So this is a yes on that one. Okay? Then we look at the second one, and we do the same thing. So I'll do 2 of x, so 2, I'll put in my x value of negative 3. Plus, or minus, sorry, minus y, which is 2, plus 3 of z, which is 4, and I want to know if that equals 4. So I'll look at the left side and solve it and see if it equals 4. So I have negative 6 minus 2 plus 12. So that's 12 minus 8, that equals 4, so 4 equals 4. So that's a yes. Okay, so I do it for the third one. 5 times the negative 3 minus 3 times 2 plus 5 times 4 equals negative 1. So I solve for the left side. That is negative 15 minus 6 plus 20. So that's minus 21 plus 20. That equals negative 1. Negative 1 equals negative 1, so that's a yes. Okay? So what I did is I took each equation and I plugged in the corresponding values into those variables, and I solved the left side, and if the left side equals the right side, the answer is yes. However, all 3 of them need to be yes for this ordered pair to be a solution to this system here. Does that make sense? So then the answer to this one is yes. Had any one of those been no, then the answer would be no. It means like one line might be intersecting, but the other one is not. So one could be parallel to one, but the other ones intersect. Okay? Alright, so that's all easy and said. Just take the values, plug them in, compare them, yes or no. However, they don't necessarily give us the points, because what we're going to do now is we're going to try and find what these points are here, solving them algebraically. Okay? So there is a process, and it is written right here. We have 4 steps that we walk through. Okay? So you'll have three equations with three variables, okay? And we call that a systems of equations. So the first step we want to do is, I always just draw a line because I'm going to divide them in half, okay? So the key is you want to rewrite them as two smaller systems. So I want over here on the left side two equations, and I want here on the right side two equations, okay? I only have three, so they do not divide nicely, so you just use one equation twice, okay? I try to find the most simple equation to use on both sides. So maybe the one that has coefficients of 1 in it, maybe ones that are easily divisible by a certain number. You make that choice, it doesn't matter. You'll get the same answer regardless of the equations you actually pick, okay? So I'm just going to pick this x minus 3y as the one I'm going to put on both sides, okay? So I'll do x minus 3y plus 6z equals 21. And I'll do that on both sides. So one will be shared on both sides, and then the other two get distributed one on the other, okay? So I'll do 3x here. And then I'll do the 2x. Okay? And like I said, it doesn't matter which one you put on either side, but one will be shared. Okay? So each containing two of the three equations. Okay? So that's number one. Okay? So then we go down to number two, and number two says you want to eliminate the same variable in each of the two smaller systems. Okay? Well, we have three variables now, and we want to get down to two variables. So you decide which variable you want to get rid of. So you look to see what seems the most simple on both sides, and that's the one you want to get rid of on both sides. I think x is probably the easiest one because you have a 1 coefficient here and a 1 coefficient there. If I choose x on the left side, I have to choose x on the right side. Okay? If I choose y, I have to choose y on the other side. If I choose z, I have to choose z on the other side. It doesn't matter which one, but you have to be the same. Okay? So I'm going to say x. Okay? So for me to get rid of x on this side, I'm going to multiply the top by -3. So I'll just do this. I'm going to get rid of x. So number 2, I'm going to get rid of x. So that's going to become -3x minus 18y. I'm sorry, minus 9y. Oh, plus 9y. Sorry, plus 9y. I'm looking at my 6z. Okay, so it's plus 9y minus 18z. Okay, and that's going to equal -39. You guys, I just crossed my z's like that so I don't get confused that it's a 2. Oh, -63. Sorry. So -63. Okay? So, just so you know, that's why I'm just crossing my z's, so you're wondering why I'm doing that, because otherwise sometimes I see it as a 2. So that's why it's that way. Anyway, so then I'm going to add the two together over here. So I'm going to get, the x will cancel. I get 2y and a 9y, that's 11y. And then I'm going to get a -23z. And then I'm going to get a -93 on this side. Okay? That's good on that? I do the same thing to the other side. I have to get rid of the x on this side. Okay? So I multiply this side by a -2 to get rid of the x on this side. So I don't multiply it by the same thing on the left. I do it all separate over here. But I have to get rid of the x if I got rid of it on the left. So that will become -2x. That will become a positive 6y. That will become a -12z. And that will become a -42. Okay? And then I'll add the two together. So the x's cancel. I'll have a y, I'll have a -10z, and I'll have a -48. Okay? So we didn't do anything differently than we did last time, except we just when we got down to the end, we still have two variables. Okay? Because we have two variables, we actually do the step one more time. So now what we do is we just put the step over, we put these two over each other. Okay? So I'm going to take my 11y, so that's step number 2, is getting it down to 1. Step number 3 then is you rewrite the resulting equations with the two variables together. So now I'm going to put these two together. I'm going to have 11y minus 23z equals negative 93, and then I'll have y minus 10z equals negative 48. So this is where we started yesterday, right? This is where we started the day before. So this top part right here is the new part. So you eliminate one of the 3, and now you have the 2, so now we start over. Okay? So we have to eliminate another variable. So now I'll eliminate the y. I'll multiply the bottom by negative 11. So this becomes negative 11y. This becomes a positive 110z. And that becomes a, what does that become? 548. 528. Okay? Good so far? And now I'm going to add the two together. So I'll take the 11 and the negative 11, and that's going to cancel out. And so I'm going to get 0y. I have the negative 23z and a 110z, and that actually becomes a 87z. And then that equals, I add the negative 93 and the 528 together, and I'm going to get a positive 435. Okay? I can solve for z at this point, and when I divide 435 by 87, z actually equals 5. Okay? So now I have a value for a variable that I know of. So all I need to do is take this value here and plug it into one of the two equations that I only have the two variables of. So now I take this and I can put it into either the y minus 10z or the 11y minus 23z. So I think I'll do this one right here. So I'm going to plug this into this one. So of y minus 10 times 5 equals negative 48. So that's y minus 50 equals negative 48. You add 50, y will equal 2. Okay? And so like I keep trying to work my way back up now. I worked my way down to one variable. Now I take this one variable, plug it into the one that had the 2, got the other one. Now I have z and y, and now I can plug it in and find x. Okay, so I have my z, I have my y, okay? So now I'm going to substitute those two into the original equation. So you pick one of these three to substitute them into. I'll pick the top one here, so that's the easiest. I have x minus, so I'll do 3 times my y value, which is 2, plus 6 times my z value, which is 5, and that equals 21. So x minus 6 plus 30 equals 21. So that's going to be x plus 24 equals 21. X equals a negative 3. Okay? So that was step number 4 right here. Okay? And this is step number 3 right here. So then I have my x, I have my y, I have my z. So if I want to rewrite this as a, quote, solution, I need to put them in an ordered pair format. So alphabetically it would be x, y, and z. So that would be negative 3, comma, 2, comma, 5. And then that is the solution for this problem. So if I take those three numbers and I plug them into each one of these, the left side here would be 21, the left side here would be negative 30, and the left side here would be negative 6, and then you would say yes to all. Because that's the point that all three of those lines intersect at. Does that make sense? So the biggest difference is just really taking the 3 and dividing it into 2, and then getting it down to your two variables, and then you just stack them and start over with what you guys just did last class period. And then once you get your variable, you fill it into the 2 that you had before, and then you get your two variables, and then you fill it into the 3. Okay? Questions on that?